What are the constraints support snowflakes? Tell me.
Primary key, foreign key.
Okay, so that's like small, unique, not null.
Not null.
Okay, primary key. Primary key. Then
foreign key.
Foreign key.
Okay, then one more thing, default constraint.
Default.
The default constraint. Okay, so now question. Okay, now tell me which one it in Snowflake, which constraint is enforces?
Not null.
Not null constraint is enforces. Okay, now we'll say some concept. Okay, now 1 second. Let me take one table. Simple table I'm taking. So when you're learning any topic, now go with simple concept. See, now I'm taking create table, employee ID, name, phone. Okay, so this is my thing. Copy the same value. So this is what you weigh? Classic constraint snow site.
Snow site.
It's a snow site. Okay. Now try to use control enter. Now see what's saying. Tell me if you want to create any database object, compulsory what should be there? Compulsory have one database. Okay, so right. So create. So, okay, database. Okay, sample. Test. Okay. Database and something like that for understanding purpose. Testing schema. So create schema testing. Okay, see database name, schema name. Tell me by using query, I want to see what is my database name and what is my schema name. Tell me what.
Testing DB is the database name. Testing
No, by using
is the
query.
Select current database.
Select current database. Okay. Select current data. These are the simple basic things. Database name and how to get a schema name, current schema. Okay, same thing. Okay, so this is fine. Okay, now in this database, in this schema, I want a list of tables. How can I see list of tables? Let's go for okay, show tables.
Shows tables.
Okay, so this is fine, no issues. Now what happened? Now try to create one table. So data is. Now try to cooperate some data. Okay, let's see one topic. Okay, insert into our employee table values 1 Praveen, then some number I'm giving. Same thing of the same value. Insert to 3 records. Second record to my friend. So third record. This is okay. So 3 records. Now, how to see this data by using what? By using select stands from table. Okay, select stands from table. This is fine, no issues. Okay. Now, point is that what? Okay, in normal SQL, how to take a backup? How can I take a backup? How can I take a backup? Normal SQL. By using what concept? By using CTAS concept. Okay, see one more time. So this is important. Now I'll see how to take a backup of a table. So this is our main table, and I want to take a backup. How can I take a backup by using what? By using CTAS. Okay, so CTAS nothing but what? So CTAS. Okay, tell me syntax for CTAS.
Create table name as.
Okay, so create table. Okay, our table EMP. So this is how many records are there here? 3 records are there. Now what happens? CTAS nothing but what? So create table name. So this is table name as select stars from old table. Okay, so this is the syntax. Okay, now so what is my table? So copy the same thing. So emit is the main table, and I want to have CTAS. Okay, see CTAS. Okay, so table has been created. Now, how to see this data? So select start from. Okay, CTAS. Now see how many records are there. So same 3 records will be populated. Now tell me how to see this definition for the CTAS. How to see definition of any table? Select this. Tell me definition of any table.
Get
Describe.
Describe
This-
columns. Okay, but I want to see definition. Create table. Okay, where you can amplify. Get underscore
this
DDL. DDL. So table. Our table name we should. Okay, so table name. Okay, so this is fine. Now copy the same thing. Now see, understand the concept. Okay, so before that, copy this value. So how to change the language? How to change the language? So go for
Language
language.
section.
Okay, yes, SQL. So that what? So keywords will be added. So we should practice the same thing. So this is which table? This is okay. This is the thing. Okay, copy the same thing. Now same value, our original table. Okay, try to see this definition. Okay, we'll see what exactly we're trying to come. So copy the value, copy the same thing. Now try to. Okay, so go back here and put here. Okay. So this is fine. Now in Notepad++, now we're having comparison now. We can able to compare. Okay, 2 notes. Okay, Notepad++. Okay. Now tell me what's the difference. This is the main table and this is the CTAS table. So by using CTAS, I have created one table. What's the difference in both definition?
constraints
So constraints are okay. What is different?
not null, not coming.
Now see here, constraints are there, but constraints are not. See, unique constraint is there, not constraints is. So what's the conclusion is that what by using CTAS, we can get the table definition. Okay, then plus data is getting populated. Plus one more thing is that constraints are no constraints are getting populated. Okay, so our point is that what's the conclusion? See, how I'm having one table or one thing. I want to take a backup. How can I take a backup by using this concept? As of now, we know in SQL CTAS. Is there any other way we can able to take a backup? Any other way apart from CTAS? Anyone knows? Tell me, anyone knows, huh? Anyone? So same thing. We are having one concept is like. Okay, see, like. So like is nothing but what? So syntax create table name like old table. Okay, so this is the thing. So create table name like old table. So copy the same thing. Okay, so copy the same one. Tell me how to see list of tables. Show tables. Okay, show table. Now copy the same value. So copy, paste, and like. Okay, see, this is fine, no issues. Okay, now what happened? Now how to see this table? See how to see the definition. Select get underscore detail. So these are the basics. Okay, sometimes I'm getting forgotten. Okay, so describe table name. What did you? Describe table name. What did you?
It will give columns.
Structure of the table.
Not structure. It will give the def like columns of a table. Describe table name. What will you do? The columns and data size. Okay. So that's but requires that what I want is the definition. Then we should go for so say names will get DDL definition. The clear of like this way is clear. So same thing now. Okay. Now see copy the same way. So now what happened? Now try to take this definition. Okay, so copy the value, copy the same thing. Now go back here and try to put in this thing. Okay. Now try to recompare. Okay, we can able to compare. Okay, now see what is the difference in the both definition DDL only name is different. Apart from C, constants are getting populated. Now, what's the conclusion? Tell me. Conclusion is that for C, like, tell me, anyone? Like, definition getting populated. So, constants are getting populated. Now, how to see this data? How can you see the data by using select star from table name? Okay, see table. Okay, now see data won't be populated. Okay, get to the point. So by using C-test, definition, data is getting populated and constants are not getting populated. Same thing like definition plus data plus no data plus constants are getting populated. Okay. If you want to create a table without any definition, okay, with all constants, we will go for like. Okay, same thing. One more important concept in Snowflake. Anybody know how to take a backup in area? And one important concept, that is cloning
Zero
concept.
copy.
Cloning. Okay, so we'll see the same. As of now, CTAS is normal thing. In Snowflake, we are seeing like same syntax. So same thing. Create table name. Instead of like what happened, what we should put? We should put clone. That's it. So this is important to see. Okay, so create table name, clone old table. Okay, so this is the main table, and we should, instead of like, we should use clone keyword. Okay, like this way we can able to make. Okay, so copy the same thing. Now go back here. Now what's the main table? So create table name. So what's the table name? We can go for our. So clone. Okay, so this is the main table. From this table, I am trying to take a clone. Okay, now see the same use case. Now what happened? Now see how to see the table. See, okay, see data is there. 3 records will be populated. Now it's the same thing. See the definition. You get some clarity. So copy the value. Now try to compare one more time. Now see which is difference. What is difference? Only the name is different. So consistency. What is the conclusion finally? Okay, so this is important.
Definition.
So C-test will get definition plus data. So same thing. Try to use controlling clone definition data plus constants are getting populated. Getting points. So this is important. By using C-test, normal thing, create table name as select star from our world table. Definition, data, and constants are not getting populated. Same thing. What about like, so we'll get definition plus no data. So constants are getting populated. In the clone table, clone of option, what happened? So definition plus data plus constants are getting populated. Okay, so and in Snowflake, cloning is important. Why its reason is that what? So cloning is nothing but what? So definition is what? It is used to take a backup or replication or what? Snapshot of a table. We can take a table or entire schema or entire database. Okay, it is used to take a backup or replication or snapshot of a table, schema, entire database with a single shot beginning. Okay, so now why it is important? Because, so remember, so cloning is called as zero copy cloning. Okay, anyone in area? What is exactly zero copy cloning? No, so see what exactly? Anyone? Okay, see what happened. So cloning is called as zero copy cloning sense. But without, okay, see, important. So without any additional storage cost, we are trying to take a backup. I will explain what exactly. Okay, see. So there, see, remember one thing, in CTS, there will be storage will be there. Okay, so here, no storage will be there. Okay, same thing. Now what happened here? No storage. Okay, now we'll see what exactly it happened. So now tell me, suppose like I'm having EMP table, it is having 1 GB storage. Now I want to take a backup. Tell me which option we should choose. CTAS like around, which one for understanding purpose as of now? Tell me.
Clone.
Clone, why clone? Why clone?
It will take 1 GB only.
Extra storage.
Okay, see now what happened when I take normal CTS, what happened? So 1 GB storage. So 1 GB storage, what happens is storage cost. Storage cost of 1 GB. So 1 GB now what happens? Now our company need to play to the Snowflake. Now what happened? Instead of this, now we should go for clone. Okay, so because it's zero copy cloning without any additional storage, we are trying to take a backup of a table, schema, all these things. Okay, we'll see simple example one more time. So go back here. So EMPT, assuming this is 1 GB storage. Okay, see now what happened now? So this is the EMP table. Now I want to take a backup. So normal thing is that what discuss? Okay, CTest. So I take a backup of one more table. Okay, see, I have taken so backup. Same thing, I have taken backup. Now see the same use case. Okay, something. Okay, EMP3. EMP4. Okay. EMP1. Okay, so one table is there. Now I want taking backup. Okay, so backup of all these things. I'm taking a thing. Okay, assuming. So this is the value, no issues. Okay, so this is fine. Our main table, EMP table is having 1 GB. I'm going for CTS. CTS in the sense like what? How many? Now tell me total storage cost will be how much? 1 GB or 4 GB for total cost?
4G.
4 GB. Okay, see. So because what is the reason? Because so they'll have physical storage will be there for if I go for CTS counts. Okay, so because we are taking the data physically. Okay, physical. Okay. Now same thing. Now same concept. Understand? Okay. So one more thing. So assume like this is the main table. Go for one more paint. Okay, so this is the main table. Okay, now what happened? I'm going for cloned concept. Okay, so before that, understand. Okay, see data in the Snowflake will be stored in micro partitions. Okay, get the point, sir. So this micro partitions one more time. So data in the database, the data will be stored in what? In the form of the micro partitions. So micro partitions nothing but what says like divided into small continuous units of storage. So big table now we are trying to divide into small micro. So it's in Snowflake, it will automatically divide into small micro partitions. Okay, so range from 50 MB to 500 MB. Okay, so in this one they'll try to divide. Okay, so simply it's a like continuous into the storage. Okay, this our data will be stored in micro partitions. Micro partitions nothing but small continuous units of storage. Okay, now come back to our use case. Okay, see now what I'm trying to say. Okay, see this image. So if you take n number of copies, n number of storage. So now what happens? Now our company need to pay Snowflake for 4 GB of storage cost. But what happened? One more option is that we are having in Snowflake is so zero copy cloning. Okay, see this is simple only. Now I am trying to take a backup. Assuming this is the EMP clone. Okay, so see the same thing. Now see this value. So see this value. Okay, now what happened? So there will be only one physical storage. In this EMP clone, what happened now? It will okay. So it will simple only. It will hold the micro partition metadata information of a micro partitions. Okay, simple. What is metadata? Is nothing but what? Metadata is data about data in the sense like what this micro parts information will be stored in this where in this cloned object. One more time. So normally what in this CTest table, so physically the thing will be stored physically. That's why 4 GB storage. But what happened here? I'm taking a back. I'm trying to create a backup with the help of clone concept. Now what happened? There will be only one physical storage What it is holding? It is holding the metadata information of the micro partition. What is it? Our data will be stored in micro partition. If you're not able to understand, so I'll show you one image, then you get clarity. Okay. Okay, so before this, try to understand. Okay, see. So for understanding purpose, we'll see later point of time. So Snowflake architecture is divided into what? So it is divided into three layers. Okay, storage layer. Okay, processing layer and the cloud service layer. Okay, see the same thing. Now understand one more time. So one second, let me. Okay, so like somewhat confusing, but it's a simple one. I'll write it down. Now what I said. Okay, it is divided into storage layer, compute service layer, and cloud service layer. Okay, so our data will be stored physically. Tell me in the form of what? In the form of what? In the cloud storage?
Micro partitions.
Micro partition. Okay, suppose like one table is this micro partition information where it will store in the metadata, that is cloud service. Suppose like simple thing. Okay, suppose suppose I want to find one person. Now what happened? This person, where you should search? Suppose like in the address register. Tell me physically the person will be there in address register. Let's say information will be there in the address register. Now physically we are in one place. Same thing. This information now where we are trying to store the metadata is stored in the metadata manager. Okay. See, physically data will be stored in micro partition. This data is there in same concept. Now see, same thing. Now I'll take a screenshot for understanding purpose. Now see data. So forget about this thing as of now. Okay, now so P1, P2, P3. So this information is stored in metadata manager. But physically it will be stored in in the storage layer. Getting a little bit. So data is stored physically in the micro partition. Okay, so this information is like how many partition? So this information will be there in P1, P2, P3. Getting a yes or no? I'm confused. Anything? Just tell me. Okay, see, data will store in physically in the storage layer. This how many parts in those informations is stored where? Is stored in the table A. Okay, table A table. Okay, now what happened? Now see, normally what when you take a backup, now see this image we are tracking. So physically, like one more storage. So like physically, one more storage. But in Snowflake, no one concept cloning. Say zero copy cloning. See what happened instead of cloning this entire database storage. Now what happened? We are trying to clone only the micro partition information. That's why it is called as zero copy cloning or the false. There will be only one physical storage, but we are trying to take a backup. So with the help of this partition information. Okay, before that, tell me why we want to take a backup. That's important. Why you want to take a backup or why you want to take a clone? Tell me. Okay, why you want to take a backup of anything?
For reference, for analysis.
Okay, if you want to do any testing or then like suppose like this table is important table. Okay, I want to do some testing. Then what happened instead of doing testing on the original table, I try to create one backup table and we can able to do same thing. Now if you want to do some backup in the sense required for protection of data. Now this data is important. Instead of then what happened? We'll try to create a backup. Then what happened for future purpose we can say. One is for testing purpose, one is for preservation of data. Okay. Now what happened? Now see why I should go for zero copy cloning. So see same thing. Now I try to create one more copy. Okay, now we'll get some clarity. Okay, now one more. Okay, see EMP. Okay, EMP. Clone one. Okay, now what happened? Tell me how much storage. So see now what happened? This one also will be one physical storage. Only the micro parts information only will get copied. Same thing. Now try to take one more cloned concept, one more object. So with different color. Now what happened? Tell me. Now see, it is taking. Okay, see, only one physical storage will be there. EMP clone, EMP clone. Next time what happened? It will hold the metadata. Now what happened? So it's again physical one storage. Now tell me. So there are totally 4 database objects. Now storage will be what? 1 GB or 4 GB? 1 GB or 4 GB?
1 GB.
Say 1 GB because no, so only one physical storage. See the same image. Okay, there will be one physical storage. Now we are take a n number of copies. Now it only holds some metadata information getting copied. So it's a 0 copy cloning. Also, there will be no additional storage cost. Only we are trying to take a backup without any access. It will only copy the metadata information of the micro partition getting copied. That's why it's a fast cloning or 0 copy cloning. Getting it? Yes or no? Yes, tell me any doubts, sir? You are able to follow. So see these 2 images, you'll get some clarity. Okay, physically 4 times the 4 GB there. But here what happened now? 4 times I taken, but it is giving only 1 GB storage. Now tell me storage cost is reducing. Okay. Now tell me as a Snowflake developer, if you want to create any table, which table you should prefer and why? Cloning or CTS? Cloning or CTS? Cloning. So now why cloning? Because so there won't be, see what happened, we are reduced 3 GB storage. Okay, same thing now suppose it's reducing 3 GB storage. Now what happened now 3 GB now we are avoiding the storage cost to the client. Okay, so we are trying, so as a Snowflake developer we should do the storage optimization also. So we are trying to see 3 GB storage we are trying to reduce. Now what happened, the storage cost will be reduced. Same thing now in a similar fashion, what? So simple thing, it is only holding the metadata information of the micro partition. See the simply. So P1, P2, P3, those information is getting copied. That's why it's a 0 copy cloning or it's a fast. Okay, clear? Any doubts?
Yeah, Praveen, if I drop the table A, so how will the clone work? Will the clone will be still available or?
No, we'll see. Once you know. Okay, as of now, this is clear. Like we'll go for data and confirm. This is clear as of now. This changes now. We'll see. We'll try to see. Okay, this is clear as of now. As of now, endorse this part. Okay, see this part. No issues. Now go back here. Now see the same concept. Okay, now so see this is important. So once you see that part, now you'll get some clarification. Okay. Now take the same value. Put here. Now how many cards are there here? So 3 records are there. Same thing here. How many records? 3 records. Okay, so this is fine. No issues. Now what happened? Now I'm trying to insert a record. So insert into EMPT or like EMPT values. 4th record, something like Raju. Okay, something like this. Okay, now how many cards will be there here? Totally 4 records will be there. Okay. Now what about here in the clone table? Clone table?
3 records.
3 records. See why 3 records? See because so after creation of this table, now what happened? So both are independent. Okay, so independent. So in the sense like whatever changes appear now, it won't be reflected. One more time. Now see same use case. Now try to insert in this particular cloned table. Okay, so cloned table. So go for 40. Okay, now see. Now 40 record will be there here. It won't be there in this table, main table, because as of now, see at this particular point of time only we are trying to take it. Whenever do any changes, now what happened? Both are independent to each other. If you drop this table also, what there will be storage will be there here. Okay, so this will be copied by this thing. Okay, the point. So see one more time. So see getting point little bit at least. Okay, so now next point is that what if you see this image. Okay, see now so next to I try to insert a record. What happened? So this will have separate storage will be there. Then what happened? It will have occupied the physical storage. Okay. As to the at this particular point of time, I am trying to take a snapshot. Snapshot in the sense like what 100 record, 100 records will be available. Next time when we do any changes, no, then what happens? So both will act as independent. Okay. If you do any changes, no, there will be separate storage cost will be there. So mainly why we will do the backup? So to do testing. Or if you want to preserve the data, okay, then what happen if any changes? Now what happen? There won't be available here because these 2 tables will access independent table. At the particular point of time only, it will sharing the same things, but what same partition. But when you do any change, now what happens? So there will be separate micro partition be stored. Okay, the points are clear a little bit. Somebody asked question, no? Clear? Same thing now. See, the same now. This is fine. Now question is that what in interval? Okay, you are saying like cloning is a zero copy. Now question is that what can you prove? No, I don't want theory. Can you prove? Okay, how it is a zero copy clone? Get the answer. So question is that what as of now you say like it's a zero copy. That's fine. My point is that what how can you prove it's a zero copy clone? Okay, so now go back here. We are having one concept. So select transform. Information schema. Okay, see this schema, there are so many views are there. Go for table, storage, matrix. Okay, so this is the table storage matrix. Search for the same thing. Okay, see this little bit. Okay, before see this is wherein this is there in Covin DevDB, Covin schema. So use tell me if I want to go for now, how to go use database. Okay, database. Okay, same thing. Covin DevDB. So simple only. If you see this image, if this now it will get some clarity. Or else like before that 1 second, let me. Okay. Now tell me how to get our database. So see here, table catalog is nothing but our database name. So where, tell me where table catalog. Okay. How to get my database? How to get this database here? I just discussed before starting the class. How to get database? What is the database name? Just not discuss how to get my database name. Select.
Show current database.
Okay. Show not select current database.
Select.
Show database list of tables, but I want my database. See, no copy. See, this is fine. Now it is giving what? See, it is giving how many records? 183. But I want to see there are so many databases, but I want to see my database. Then go for parent. This is called filtering concept. Okay, see how many records will be there? See, as of now. Okay, semicolon. Okay, same thing. Okay, so see, this is important. Okay, so here this table will hold the next view will hold the storage thing. Okay, copy the same value. Okay, see. Okay, see the same thing. Now what happened? EMPT, EMP clone. So see. Now by seeing this image, tell me which is the main table and which is the clone table. Any idea? Anyone? So seeing this image.
First table, main table. That the name itself it is coming. Clone CPS like.
Come again. Anyone tell me?
By saying clone group ID, we can.
Okay, name. So by name now it can be anything. I put EMP1, EMP2, EMP3. Then how can say main table? Suppose I put EMP1, EMP2. So okay, now it's not. Tell me how can you see?
We can differentiate like a ID and clone group ID.
Okay, see
Clone
the
group
same.
ID and ID both are different.
Okay, see now what happened? See ID clone group ID. So see this is so 30738. So 30738. Okay, so this is now see the same thing. Okay, what happened? So okay, so both are same. Same thing like both are same. So see test both are same. So then what about clone? Tell me. So 30738.
30.
Okay, see 3078. Now see 73. Now see the same thing. 38. Now EMPT, EMP cloned it. Now see both are same. This is the main table. Now this one is getting cloned from what? This table. Okay, get the points out here. See. So whereas other table like C test like no, there will be separate ID clone group. So both are same. These are the main tables. So these are the main table. But clone is no what happened is it is popping from this particular thing. Okay, now this is called as so zero copy cloning. And one more thing is that suppose like assume like here 100 bytes storage is there. Okay. Now what about in the EMPT? How many bytes it will be there? EMPT like it will be for like normally suppose like
100 bytes.
It will be 0 because so for like now, for like what storage will be there? For like there won't be any data. When data is not there, then only there won't be any storage cost will be there. Okay. Now what about CTS?
100 bytes.
100 bytes because physically we are trying to take a backup. What about clone?
0 bytes.
So 0 bytes because so we are trying to take only the metadata information. And before that, understand, so this data to be reflected will take around 2 hours to reflect in this particular way. Okay, so try to create, okay, for as you know, so the task is that one. So try to create one EMP table, okay, insert at least 100 records, like some data, 100 records. Now try to go for EMPT like, okay, then EMP, CTES, and one more thing is that what CTES, and one more thing is clone. Okay, now so see after 2 hours, try to see in this particular view. So it because it will take some latency to get popular. Okay, see after 2 hours, try to see what happens. So it will be have 0. It will have, okay, suppose like it's a 100 bytes. It's not going. So link experiment come 100 bytes. So 0 bytes. What about here CTES? How many bytes? It will be 100 bytes. What about clone? How many bytes? Clone?
0.
0 bytes. Okay, so 0 bytes. Okay, so because it's a physically, okay, so we are not copying physically, we're trying to take only the micro partition metadata information. Okay, that's why it's called as zero copy cloning. Okay, so now getting a little bit, yes or no? So see, now it's some latency is there. Okay, so that's why we can't able to understand. After 2 hours of visit, now data will be 0 here. Same thing just now discussed. Now, see, go back here. Link expert come back. We'll see the same use case. Okay.
Hello.
Yes, yes, yes.
When we are taking the clone, anyhow we are getting.
Tell me what is the question you are asking?
Yeah, I have a doubt. When we for a particular table, we'll get entire data, exact data. Then
Okay.
how it will be 0 byte?
Yes, that's what now we discuss. Okay, see this same thing now. Okay, so we see this image. You got anything else? Image? No.
Yeah.
Now what you're trying to copy here? So we are not copying this data. We are trying to copy the micro partition information. Okay. So micro partition. Okay. So because of this, what happened? There will be only 1 GB storage here. So we can take n number of copies. There will be 1 GB storage. See. So this was now we discussed again. See? Okay. Here we are taking copy. So by using CTAS. So it will be physical storage. 4 GB will be there. When I go here, what happened? Okay. See, there will be only 1 physical storage. We are trying to clone multiple things. Okay, so there will be only 1 physical storage, and so this micro part, like suppose there are 3 micro parts in MP1, MP2, MP3. Those information only we are trying to copy. But physically storage will be there. Okay, that's why it's a 0 copy clone without any additional storage. We are trying to take only the micro partition information only we are trying to clone. So actual data will be there here. If we see these 2 images, then we'll get some clone. Okay, so see, there'll be, we are not taking one more MP1, only 1 MP1. So this is the thing.
Okay.
In that case, our like also come 100 bytes, right, sir?
Come again.
For like, you mentioned 0 bytes, no? So it will be 100, right?
No, like, no, there is no data, no, like.
Oh, no data. Yeah,
No, when
definition.
no data, no, then there will be no storage. No?
Okay.
Only definition is getting copied. Okay, so in the like, only data will, okay, so data will not be followed, remaining things will be followed. So in the CTAS, no, definition plus data, consensus, no, what happened, storage will be there. But in the clone, what happened, there won't be any storage, just we are, so that's why it's called as 0 copy clone. Without any additional storage, we are trying to take n number of copies. It only copies the metadata information. Actual data will not be copied. Only the micro part, that is the details of how many partition, those informations only will be copied in the, okay, copied in this cloned thing. Okay, see, table be cloned. So S1, S2, these are the micro partition information. It will be copied. Okay, so data, if I create one more time, what happened? There will be one more clone, one more thing will be there. Getting a little bit? Yes or no? Yes, getting
Yes.
it? Okay, so now we'll go for, okay, intro questions. Now we'll get some clarity. What exactly we're doing. Okay. So a little bit confusing 1 or 2 times if I try to solve same thing. And after try to create this table, the task I'm giving. See, create 100 records, some dummy data. So see for so wait for 2 words and see here 100 bytes, 0 bytes, 100 bytes, 0 bytes. Then we'll get some clarity what exactly we're trying to discuss. Okay, go back here. Now try to take the same use case. Okay, see the same use case. Now what happened? So go for cloning. Now see this value. The intro question. 1 second. Let me zoom it. Okay, see what is cloning? Tell me. Cloning is nothing but what? Cloning is what? It is to take a backup, a replication, or snapshot of a table. Or we can able to see same thing. Create tables. We can go for schema. How can I create the schema? Schema. Tell me. So same thing. So create schema. Schema name.
Schema.
Okay, clone old schema. So this schema, enter schema, same thing. How to create a database? So create database name and old database. Okay, we can able to take entire database. We can able to create take our entire schema. I can able to take a simple table. We can able to create. Okay, getting a little bit. Okay, like this. Okay, so same thing. Okay, suppose so go back here. Show tables. Okay, now what happened? One thing other we are see here 4 tables. Now I want to create entire database. So create database. Suppose like something like E2E database. So clone from where we need to clone? From the testing DB. Okay, so now what happened? How many objects will be cloned? So see. Okay, so go back here. So ETD database. Okay, so 1 second. So see we can able to clone entire database. See. Okay, database. Okay, schema. Now go for show tables. How many tables will get? 4 tables will be 4. So we can copy. You can clone entire database, entire schema, or single tables. We can able to take all this. Get in a little bit at least. So this is the syntax. Syntax will answer. Tell me syntax is but so create database, database name, clone old database. Same thing. Create schema, schema name, old schema. Okay, so same thing. Create table, table name. So we should use clone. Okay, like clone same thing, but in like no, there won't be any data in clone. They'll have data, but they'll have no physical storage. Okay, only one physical storage will be there. Okay, now tell me in a similar fashion why cloning is called as zero copy cloning. If you understand, you need to say. Tell me one.
Only the micro copy we are storing.
Okay, we are taking only the micro partition information. Okay, physical data we are not trying to store. Okay. Now, in which situation you have used cloning in your project? Tell me. Anybody must know what's the answer? For testing purpose or for data preserving, we are trying to take a backup. Does cloned object will have storage? Cloned object? No. Okay, because that's what no. It says zero copy cloning. Okay. Now, when you make any changes to the cloned object, does it get reflected in the base table?
No,
it won't.
Because both are independent to each other. This is the thing we should say. Okay. Now view to check the storage of a table. Tell me important. Okay, view to check the storage of a table.
Select information object.
Information schema dot what?
Schema.
Information is good. Table storage
matrix.
Okay, this is important. So information schema dot table storage matrix. Okay. So which is the column name? Active bytes will be 0. Active bytes. Okay. See now a new record insert in the clone table. Does it have storage or not? Suppose like a new record insert in the clone table. Does it have storage or not?
Yes. Storage will be occupied.
Because no, it's a new record. New record in the sense like compulsory will have storage. So this is like it will store in the new micro partitions. So see, so see this image. So production data for testing purpose, we can able to dump it to like the same thing. Now see, storage will be there. So where it will be stored? Next question, sir. So does it have storage? Yes. if storage is there, where it will be stored? In the new or additional micro partition, this data will be stored. Getting the points, in the new micro partition. Okay. Now same thing. Can you perform DML operations on clone tables? Tell me. Can you perform?
Yes.
Yes. Okay.
Yes.
How will it
Yes, we
impact
can
versional table?
perform.
How will it impact versional table?
No impact.
It won't
No.
impact.
No,
No,
because
it won't
both
impact
are independent.
because it's individual.
Independent. Okay. So at the particular point of view, we take snap. If you do anything, what happens? There will be storage cost there, and this is separate storage will be there. That's it. Okay. So main purpose of anything now, we want to do testing. Instead of going for C test, now there will be suppose like 10 GB storage. So what happened? So 10 GB we should pay. So it's a storage cost. Okay. Unnecessarily we are trying to give the storage cost to the customer. Okay. So now what happened? Instead of this, we should go for cloning because it only holds the micro partition. Now, so you should understand the concept is that what. So why we need to go for zero copy? To reduce the storage cost. Okay. Snowflake provided one feature. We can able to take n number of cloned objects of entire database without any additional storage. Now we can able to do any type of testing. So it's a zero copy cloning. It only holds the micro partition information it is going to copy. So these two images, okay, see, new changes, same thing. See, C test, physical storage. Getting a little bit? Yes, no? Like this way, you should understand the things. Okay, once you're comfortable now, these things are simple. Okay, so zero copy cloning without any additional storage. We are trying to take a backup. Okay, so it only holds the metadata of micropartition, like which information, like how many records, those information only getting copied. Same as address. So physically we are present in one place, but in the address register we are having the data. But physically where we are storing in the our address. Same thing. Physically data is stored in micropartition storage layer. But this information, like how many partition, those information in the table in the metadata layer. Clear so far a little bit?
That micro partition will take any memory?
This is the storage. Micro partition elements is storage units. Okay, so data will be stored in the storage unit. So storage element, it's a physical storage. It's a continuous units of storage. Our data, big data is divided into small. It's called as micro partition. So micro partition nothing but say continuous units of storage. Like memory, you can say memory. Any notes, anyone? So try to create this table. Okay, insert some data, but okay, at least 10 to 8 records. So try to create clone like C test. See after 2 hours, there is some latency. Then you will get confirmation. Okay, so zero copy clone is getting storage or not. Those things you can able to get some clarity. Yes or no?
Sir, when you are inserting new data, it will go for new micro partition part. If we delete some data in the physical table, the micro partition will get deleted or it will be same, no sir?
One more time, question.
For example, the partition that in the table one, some record we did. After creating this one, we deleted some record. Previously, we inserted new record, so MP4 it came. If after creating this one, some records we are deleting in the physical table. So it won't impact this MP4, MP3, MP2, right?
MP3. Okay, so remember the deleted record, they try to preserve somewhere, okay, for time travel. Okay, so tomorrow's topic, time travel. Okay, so what happened now? We can able to access historical. So what happened now? You deleted one data. Okay, we can able to get the data with the help of time travel. Okay, so Snowflake will preserve this the data, the deleted data we are preserving to perform time travel to access historical data. Okay, so once you tomorrow topic, these two topics will be linked up to each other. Okay, because so whatever do any changes, what happens? Snowflake keep on tracking. Why they keep on tracking? Because they want to they want to get the data back by using time travel concept. Okay, so remember one thing, micro partitions, these are immutable. What is immutable? Tell me. Any area immutable? So data once stored, what happened? We cannot able to change. Okay, that's what's saying. Okay, so we'll see the same thing. As you know, understand. So see, data is stored in micro partitions. It's a continuous units of storage. Okay, small partitions. Okay, they're trying to. Now what happened when you are trying to take anything? What happened? It won't be any physical storage. Only see this image. Okay, physical one time. If you go for one more thing, it will be only one. Getting a little bit at least? Okay, chalo.
Yes,
Okay,
sir.
okay, so like, okay, understand this thing. So try to create those tables, 4 tables. Okay, so do things and try to create one more table, okay, with different name, and try to see, do any changes. Okay, it will have no because so both will access independent table, and main table is information schema dot table storage matrix is a view. Active words will be 0 for clone. Then we can get conclusion that it's a 0 copy clone.